All right, welcome to NGA's Thirsty Thursday webinar today, Energy Code Evolutions 2020. This is Sarah Neiswanger on behalf of all of us at the National Glass Association. Thank you for making time in your day to join us. Before we begin, we'll review some of the features of this Microsoft Teams meeting. On the next slide, you'll see at the bottom of your screen, you should have a control panel that shows icons for a camera, chat, microphone, and others. Click on the microphone icon to mute yourself while our speaker is presenting. Please also click the camera icon until you see a slash covering it to ensure your video is also turned off. We hope you'll have questions to ask of our presenter today. To do so, click on the chat button, which is the speech bubble icon to the right of the three dots, and type your question into the message box. Questions will be addressed near the end of the presentation. If you're having trouble with computer audio controls for the meeting, you may wish to call into the meeting. On the next slide, you'll note the numbers on the screen, which were also sent to you via email. NGA's Glass Conference is just over a month away. This is an interactive online event full of a variety of presentations with opportunities for live Q&A with speakers. At just $50 a day, it's one of the most inexpensive 3 days of learning you'll find. We encourage you to register at glass.org and also share it with your peers. We do appreciate your feedback on webinars like this one. You'll receive a prompt via email immediately following its conclusion. And thank you in advance for taking just 2 minutes to share your thoughts. Now I'm pleased to introduce today's presenter. Dr. Thomas Kulp is the owner of Birchpoint Consulting. He has spent the last 21 years in the glass and window industry in the areas of energy efficient glazing and window performance, low-E glass coatings, and building code development. He is co-vice chair of the ASHRAE 90.1 Standards Committee and is an active participant in the International Code Council development hearing process. He serves as the Energy and Green Code Construction Consultant for the Aluminum Extruders Council, for us, the National Glass Association, and our committee, the Glazing Industry Code Committee. Tom, welcome.
All right, thank you, Sarah. So we're going to try and cover a lot today. At a very high level, we'll be going through a number of updates about focusing on energy and green building codes, both on the commercial and residential side, and how these affect fenestration and glazing products. Before we kind of dive into all the updates and what's going on, I usually try and highlight, what do we do with NGA's advocacy? And the way I like to describe it is we defend and promote. So we defend against changes harmful to the industry, and we promote the positive attributes of glazing in the B&C sector. And we cover a wide range from, in the building codes, fire codes and standards, glazing standards, both in the US and internationally. And my area of focus is really on the energy and green codes and standards. And that's what we'll be talking about today. But in general, just as an example of what we do over the last 10 years, if you take a look back, first on the defense side, first and foremost, we have to protect our industry, and that we stopped multiple attempts to reduce window area that would harm occupant health. We stopped proposals with where products are being misapplied. Could be a conflict with other building requirements, could be cost prohibitive or impractical, and so forth. And we've stopped proposals that restrict compliance flexibility, which is not good for either the builder, the building owner, or the manufacturer. And then on the more positive side, promotion. We try and promote to grow the pie and expand our industry. And that includes expanding dayline and views requirements, which not only is good for glazing, but it's good for high performance buildings. We've advanced requirements to promote energy efficient products where it's cost effective and practical, and that also allows you to sell higher value added products. We've increased compliance flexibility for existing building retrofits, which is an area of growing importance as we try and address energy efficiency across the world. We can't ignore our existing buildings. And we've improved credits for, products that are outside your standard windows. So shading, dynamic glazing, BIPV, vacuum glazing. So that's kind of an example. And today, we're going to focus on kind of the latest updates, what's been going on in some of the core energy and green building codes like ASHRAE, IECC, both on the commercial and residential side. And then those are kind of at the national level. Then I want to focus on some of the newest things, some real recent news coming out of California and New York City, as well as some opportunities on the retrofit side. And then finally, we'll wrap up with the National Energy Code of Canada and some proposals and changes happening there and news coming out of Canada. So that's a lot to cover. So I'm going to be trying to go through it. We're trying to pack a lot in. Some things I'll kind of cover at a high level and just have to gloss over. But please feel to ask questions, and I'm willing to stay on after the presentation as long as possible, as people want to answer questions. And also feel free to reach out to myself or Irma Sowell, who's the technical director for NGA and oversees all the advocacy work, and we can help answer your questions. So I'm going to start off with ASHRAE 90.1. So ASHRAE 90.1 is really the main energy code or standard for commercial buildings, including high-rise residential in the US, but really it's also used in various places around the world. So it is trying to, it's not used everywhere globally, but it is written to be used anywhere. So, and the latest edition is the 2019 edition, just published last fall in October, and it will also be referenced in the 2021 IECC, which it will be published later this fall as well. And the biggest focus was we worked several years on updating commercial fenestration criteria. So just in a very general sense, we had to work through a detailed cost-effective analysis to show energy savings that met certain cost targets and was also technically feasible and practical for the industry. And in the end, we ended up with another kind of step in improvement in U factor, 5 to 17% reduction in U factor across different zones. Only modest reductions in solar heat gain, but a change in format, which I'll show you these in a second. But one way I've kind of encouraged people to think about it, if you're looking at the next version of 90.1 versus the previous version, it's very roughly a zone shift. So what was required in zone 7 moves to zone 6. What was required in zone 6 moves to zone 5. And this gives a lot of, I guess, assurance or security to our manufacturers, because if they already offer a product for a certain zone, they don't necessarily have to go do a complete product redesign. It's just that they may have to offer their more northern product to an extended range further south, and that's actually a good thing. And then very importantly, no reduction in window area. They've kind of learned their lessons for the most part that reducing window area is actually counterproductive to a high performance building and can harm the health and well-being of occupants. But I will be talking about a proposal up in Canada along those lines at the end. Also 90.1, it expanded to require more and better daylight controls, which is obviously good for the connection to daylighting and glazing. There are new commissioning requirements, which will include more focus on air leakage, which for our interest really air barrier inspections and testing and paying attention to that interface at the where the window system meets the wall. And then we also cleared some barriers for use of vacuum glazing, VIG, indoors and walk-in coolers and freezers. New product, and so we wanted to make sure that there's nothing in the code that prevented their use. So as we go through today's presentation, and you'll hear me talking about zones. So if you're not familiar with this already, this is the climate zone map for the US, and it kind of extends up into Canada, and there's actually similar maps for anywhere in the world. But it goes from like zone 1 down in Miami, numbered upwards as you go further north, all the way to zone 8, which is up in Alaska and the Arctic. I live here in Wisconsin, right on the boundary between 5 and 6. So here's the big table, all the numbers. I put this up there because it shows how have commercial vertical fenestration U factors progressed over the years from 2009 up to 2020-21. And So if we just zoom in on one area, so this is for the fixed windows and these zones 3 through 6, so kind of across the center part of the US. Just look at any one of these rows and you'll see that, or columns, and you'll see this steady progression from 2009 to the current day, a steady progression in your factor. And this is an ongoing trend and has been for a long time, increased focus on energy efficiency and pushing more energy efficient products, yet being cost effective and practical with each step. And then on the solar heat gain side, it's a little different. That solar heat gain numbers were very stable for a long time, with low solar heat gain in the south, and then more moderate solar heat gain in the center and north. In 2016, they made some small adjustments in the center of the country to kind of smooth out that transition. And then also there's a new climate zone 0 that came up in 2016. And that does not occur in the US, but it's the extremely hot area in the Middle East and India and certain parts of South America. So it's an extremely hot climate that they added. And so there's a very low solar heat gain there as well. So what is new in 2019 is that there's a different format. So you see a lot of numbers there. And the key difference is now the solar heat gain requirements have separate numbers or requirements for fixed versus operable products. And the U factor already does that. So in a sense, it's really not that different. And it looks like a big change, but it's really not. The changes are small, and despite the numbers being different, it does not require different glass. It requires the same glazing type. It's just accounting for the fact that operable products have a higher frame to glass ratio than fixed products. And remember, all U factors and SHGC numbers are whole product numbers, including the framing and the glass, not just the center of glass. So these are actually, the same glazing type. And the only real change was in zone 1, which in the US is Hawaii and Miami. There's a greater area of zone 1 in other countries. But here it did change down to a 0.23 solar heat gain fixed, 0.21 operable. And that will require these new lower solar heat gain triple silver products or a tent with low E. So that's really the only real change that occurred in this. So what does this mean in real life? So if you take all the U factor and SHGC numbers, what's this mean? No big surprise. It's really the next step in efficiency. Improved framing with higher performance thermal brakes. So not just your standard thermal brakes, but things like double pour into bridge or wider foamed polyurethane technologies on the polyurethane side, or these wider strut system and complex shapes and really advanced shapes on the polyamide side. But improved framing, you're going to see more warm edge spacers, more argon gas fill in places that maybe didn't use it before, increased use of forced surface low E coatings. So it's the next step in efficiency of using existing technology, but just using more of it. And then because of the increased focus in envelope commissioning, there's going to be more attention for the installers and glazing contractors at the air barrier continuity. But despite coronavirus, none of this, my world and the code world, nothing stops. We've been working steadily on the next round of codes, and so that's the 2022 edition of 90.1. And first off, they're going to focus on opaque walls. We've done multiple steps on fenestration, and opaque walls have not been updated for about 10 years. So they're looking at that. As part of that, though, they may need to overhaul the spandrel criteria, which are treated like steel-framed opaque walls in the code, which is not always appropriate. So we will be looking at that. And then the second item up there is really a big deal. It's a new prescriptive requirement for a minimum amount of on-site renewable energy on all new buildings or building sites. So it can be any type of renewable energy, but the easiest way to comply and most common way to comply will be photovoltaics, rooftop PV, ground-mounted PV systems on the site, or BIPV. And this is a big deal. California has a similar prescriptive renewable energy requirement for single-family homes, but that's just one state. This is the first case of a national model code putting a base energy code, not a green standard, not a LEED voluntary program, but a national model code putting in renewable energy. So it's a big deal. Unfortunately, it did not make the 2019 edition, but it will publish later this summer and be available for use by states and local jurisdictions. There's also a new envelope backstop requirement, and I'll be talking a little bit more about that later. It's now complete and will be in the 2020 edition. There's new thermal bridging requirements that have gone out for second public review, and they're working on addressing public comments. And for those who aren't familiar, thermal bridging, or the idea is trying to reduce bypassing of insulation in all parts of the building, parapets, balconies, floor slabs, and then for our interest, where the window system meets the wall, making sure you don't bypass insulation. And this is really for colder climates, so the northern half of the country. And one way you can think about it is we're used to looking at drawings and trying to control water and air and draw your continuity in the air barrier. Now just add thermal in there, where you're going to look at controlling and keeping a continuous thermal line and that you're not bypassing insulation. And then finally, on the subject of air, they're still debating requirements about when they should require whole building air leakage testing versus just a air barrier inspection. And that's kind of an ongoing debate, so we don't know where that will land yet. Now, also over at ASHRAE 189.1, they control the technical content for the Green Code, International Green Construction Code. And that's wrapping up this fall. The 2020 version of 189.1 will be published this fall, and that becomes the technical content for the 2021 IGCC. And they are doing a new format where they're going to take all the requirements they already have, plus new requirements, and they're classifying them either as core requirements, which must be complied with for every location, every building type, and above core requirements that are selected by the jurisdiction. And this is to try and encourage wider adoption, where jurisdictions can tailor the Green Code to be more suitable for their own needs. So for instance, water use requirements are very important in the Southwest, but where I live in Wisconsin, they're maybe not quite as important. So a jurisdiction can decide based on their own needs what to include. But for us, in terms of glazing and fenestration industry, the last edition, we were successful in expanding the daylighting requirements to more spaces. So that requires more and better lighting controls and new and minimum effective aperture. That's minimum window area in classrooms, conference rooms, breakout rooms, offices, and so forth. So that's more daylighting. And that was really put in there for energy reasons. And then for this upcoming edition, there's a new above core requirement for minimum views in offices, classrooms, and patient rooms. And that's not there for energy. It's not part of the electrical daylighting. This is there for human occupants and indoor environmental quality. In other words, providing access to views and the natural light has all sorts of positive health outcomes, productivity, patient recovery rates, and so forth. And they want to account for that in a minimum views requirement, which is very good for us and good for high performance buildings. And then there's also expanded renewable energy requirements. They already have requirements for on-site renewable energy, but now they're expanding that to give credit for off-site, things like direct own or community owned or virtual PPE systems. So this is good for PV, but all sorts of renewable energy. So now jumping over to IECC. So IECC is the other major energy code. It's also used for commercial buildings in the US, and then it's the primary energy code for residential in the US. The 2021 edition is basically complete. They completed their cycle last year after 2 public hearings and then online voting. Now, you may have seen in some of the trade press, some very unusual outcomes happened in the final online vote that reversed and approved items that were previously disapproved at both of the earlier hearings. And a lot of people are calling these zombie proposals just because they refuse to stay dead. And most of these were on the residential side. Now the board, ICC board, has certified the results following a careful review by the staff to make sure they were legitimate. But the ICC will be hearing 4 appeals on the Energy Code prior to publication. Now, it's not expected that those appeals will really change anything in the 2021 IECC. I mean, we could always be surprised, but it's unlikely to change anything. But it will put more focus on, are there certain loopholes in the rules that they need to close for next cycle? Now, these so-called zombie proposals or voting flips did have a significant impact on builders, especially in cost. As an example, requiring a huge amount of attic insulation in southern warm zones where it has like a 500-year payback. And issues like that will possibly slow state code adoption. So that's the biggest thing that I'm watching from our interests, is that it could slow state code adoption as they sit there and fight about all these changes when it gets to each local adoption. But I do want to point out that even though it's been in the news and it sounds like a big deal, our industry was not significantly affected by these voting changes for the most part. And a lot of that is because we negotiated agreements on key items ahead of time. And so that they were on the consent agenda and not subject to this online vote. So we are in a good position. So first, on the commercial side, which does include high-rise residential, the main focus was trying to align with ASHRAE 90.1 2019. So that's where we negotiated with others to unify the two codes. And so the commercial fenestration requirements, all those U-factor SHGC numbers are now the same in both ASHRAE and IECC. IECC also updated to use the same climate zone map that I showed you earlier. We also cleared this vacuum glazing and added the daylighting control. So there's a lot of consistency between 90.1 and IECC in areas that matter to us. IECC does do a few extra things that ASHRAE does not do, at least not yet. One is a new point system where you have to comply with all the main requirements. And then on top of that, you have to earn points based on your zone and building type for doing different extra things. And there's a whole list of things you can do. But the ones that are of interest to us is they give credit for on-site renewable energy, better windows, or tighter air leakage. So it's a way to encourage people to go a little bit beyond code, but still provide a lot of flexibility. And then they also added, and these were some of the voting flips or the zombie proposals that got changed in the final online vote. They added new electric vehicle ready requirements. They added a new voluntary appendix for net zero energy buildings. So again, for our interest, really no negative impact from the online voting changes on the commercial side. And in fact, there's an indirect positive benefit for PV glass, photovoltaic glass. So we're okay there. Now, on the residential side, there were a lot more voting changes. Now, most of those are actually, they will not affect what some may call standard windows. Your standard Energy Star rated window will comply, no serious change. But it will reduce flexibility for non-standard products. Either products that are not just your standard Energy Star window, or maybe you're using some sort of custom window, or using a curtain wall in a high-end home, things like that are going to have some issues. And there's some very confusing backstops, overlapping backstops I'll show in a minute, that resulted from these voting changes that they're going to have to clean up. But for the main criteria, there are only small changes in the prescriptive U factors. It'll be a U factor of 0.30 in zones 3 through 8. It used to be zones 5 through 8, so they just kind of moved it down a little bit. But it does include an allowance up to 0.32 in the windborne and debris regions, or for higher elevations, to kind of accommodate a little more flexibility in those products. The one voting change that did directly impact us was that they introduced a new maximum solar heat gain of 0.40 in zone 5. That's like Chicago. Before, that was just no requirement. You could use whatever you wanted, low or high there. Now, to be honest, 0.40 solar heat gain is easy. There's no big deal complying with that. It is a little bit annoying because all the work from Energy Star and LBNL shows that limiting solar heat gain in cold places like Chicago can sometimes actually hurt your energy efficiency. So it's annoying that this was added in there versus providing just the consumer to choose, but it is what it is. And then lastly, there's some changes that require the overall performance path to be a little more increased efficiency. And that's going to create some indirect positive pressure for forced surface low E coatings or triple glazing. So it's not directly required, but you might see some increased demand for that. So don't worry, this is a big, ugly table. But I just wanted to show you a little bit of what happened as a consequence on the residential side windows. So now in the bold on the left side, that's the main prescriptive criteria, and really not a big deal. It's now just a more uniform 0.30 for most of the zones. The one change is highlighted in red there, where they added the 0.40 solar heat gain in zone 5. But then all this other stuff to the right, the energy code has multiple compliance paths besides the prescriptive path. You can do a UA trade-off on the whole envelope. You can do the whole building performance path. You can do the ERI path, which is like a HERS rating, either with or without renewable energy. And all these voting changes made this confusing mess, and there's different window backstops that no matter what you do on your performance trade-off, that your window can be no worse than the values shown. And as you can see, they're all over the place. So it's going to be confusing and something they're going to have to clean up next time. So that's kind of the national model codes. And I wanted to jump into some regional activities where there's been some recent news and activity. So, in the US as well as Canada, the legal authority for the building code is at the local level, usually the state or the province, can also be down to the specific cities or counties. So all the work on ASHRAE and ICC is to establish a national model code, but then it has to be adopted by the states, and that's kind of done each state does it on their own schedule. California is different. They do their own thing. California is a little different in many ways, and Energy Code is one of them. They have Title 24, and they're working on their 2022 edition. They've been going through a series of stakeholder meetings, and they're working on some draft, what they call case reports, which shows their initial proposals, and they're trying to finish that up this fall so that basically they can enter their official rulemaking phase next year. So what's being discussed? There's no official proposals yet, but there are concepts out there. First, in single-family homes, it's easy. No new changes for windows. And that's because they made a change in 2019, just recently, U factor 3.0, solar heating of 0.23 in most of California zones. And so they just made that change, and they said, okay, fine, we're just going to leave it be for this next edition. Multifamily, there's a discussion of a possible new separate standard that would cover all multifamily, whether it's one story or super high rise. And so, which are obviously, like looking at those pictures, very different types of construction types. And so that's a question they're trying to look at. How do you account for windows in low rise versus high rise, considering different construction, structural requirements, product types, and so forth. And so we've already been talking with them about different, some of the different issues, and they'll be working on this and are trying to have a draft case report for public review later this fall. And then on the non-residential side, they are proposing improvements to require better daylighting controls, update their shading factor calculation, no changes to window area. We were able to talk them away from that to not touch window area. And they're also not changing their VT requirements. They're making some small updates to the curtain wall and fixed window U and solar heat gain numbers, which I'll show you. And in general, the U factors are reasonable. They're not a big deal. Will require energy efficient technologies, but better frames and spacers and gas fills and low E, but it's reasonable. But there are some nuances in the solar heat gain VT numbers that may split hairs between glass products. And so on this slide, I show the table that they're proposing, and the proposed changes are shown in red and yellow there for curtain wall and fixed windows. And when you start to dig into the solar heat gain and VT numbers, they already require triple silver low E to meet that combined SHGC and VT. It's a triple silver market. But when they're changing the solar heat gain numbers but not changing the VT numbers, it created this real subtle nuance where it could possibly require different glass in curtain wall versus fixed windows. So different glass on the building, in the different product types, unless you use a performance path. And that's a concern aesthetically and for architects and designers. And just to show you kind of what I'm talking about, on the curtain wall side, when you dig into the numbers, the first generation triple silvers will comply with this, but not the newer lower solar heat gain triple silvers. They'll meet the SHGC, but they won't meet the VT. And then conversely, over in the fixed windows, the lower solar heat gain triple silvers comply. These are like the 0.23 type products, but not the first generation triple silvers, which come in around 0.25. They'll meet the VT, but they won't meet the SHGC. So we raised these issues with California, so they're aware of them and they're willing to consider small adjustments. We don't know what they're going to do yet, but we should see a draft case report from them soon. Now jumping to the other side of the country, going over to New York City. New York City's been in the news a lot the last year. And so I first want to start off, I say this every meeting now, just fact checked. The new stretch code requirements that New York City is already using and announced last year do not ban glass. They do not ban glass in any way. It was just a talking point, no truth to it. When you look at the actual U factor and SHGC numbers, which are shown there, they're really not that hard. It will require a standard thermally broken frame, low E, argon gas fill, maybe warm edge spacers, but it's not that hard. It's an efficient product. It just means you can't you can't value engineer away some of those things, which unfortunately in the past was common in New York City. But the new news out of New York City is they did just announce another step in their energy code starting in May, so last month. So this is there for new permits. They kept the same U factor, 0.36 for curtain wall, but there are new height-based requirements for windows. And it's for fixed windows, it's going to go from if you're above 95 feet, your fixed windows are a 0.36 U factor and your operable windows are 0.42. If you're below 95 feet, now your U factor is 0.30 for fixed windows and 0.40 for operable windows. And to be honest, it's a little weird they came up with this. I don't know if they're trying to account for structural differences in wind loads on the ultra high rise or not, but it's a little odd. And it's very aggressive. The low rise, not low rise, lower than 95 foot numbers are quite aggressive. It will require these newer higher performance thermal breaks along with everything else, but they are achievable, but it is very aggressive. To me, it's more that it'll be interesting to see how this is actually implemented in real life. Are they going to actually have different windows above and below 95 feet on the same building? I'm guessing probably not. That they'll push people, and especially for these tall buildings, to go into the performance path and then use trade-off to use the same type so you have the same aesthetic appearance above and below. And then also they need to do a little bit of cleanup. They need to clarify that the curtain wall values also apply to window wall and storefront, because right now it doesn't actually say that. Now, one thing that New York City did do, along with Washington State and Massachusetts, is they did implement some new envelope backstops. And so these are called envelope trade-off limits, or backstops, and they're right now in New York City, Washington State, and Massachusetts. And basically what these are is they require the envelope to meet the baseline performance level, even if you use the whole building performance path. So if you show the same or better energy performance of the whole building with advanced lighting and mechanical equipment, you also have to show that your envelope meets some baseline performance. ASHRAE 8.1 has also been working on a similar backstop, and it's now done, and it will be in the 2022 version. And it's a reasonably flexible backstop similar to New York City. And I'm not going to go into all the details. There's a lot of nuance with this. I urge you to go to the April issue of Glass Magazine. The link's on the screen, and you can look it up. There's an article we wrote in there going into more detail about backstops. Basically, there's pros and cons to these. On the plus side, they reduce value engineering, and so it allows you to keep and sell higher value added products in your projects. On the negative side, there is a potential negative impact on window area for highly glazed buildings, depending on what type of window products you're using. So again, go look at Glass Magazine and for that article. Now, one other thing that New York and Washington did, and it's very good for us, is they're opening up retrofit opportunities. So New York City Local Law 97 and Washington State HB 1257 have set carbon or energy limits for existing buildings. So now this takes the building energy disclosure laws to the next level. These are, instead of just having to report your building's energy use each year or every other year, you're actually given a fine if you exceed a certain limit. They're starting with the largest and worst buildings in 2024 for New York City and 2026 for Washington State, and then over time we'll expand it to cover more buildings. And this is a big deal. It will create a large incentive to upgrade existing buildings. These are not small fines, hundreds of thousands of dollars for some of these buildings. And rather than give several $100,000 bill to the mayor every year, these building owners are saying, well, I might as well at least invest it in upgrading my building. And that's the whole point. And so that should encourage us in these markets to see more glazing and window replacement, more of these secondary glazing systems where you add glazing to existing glazing. There's different ways of improving your window envelope. And so I did want to point out, in addition to NFRC rating, primary windows, there's the Attachment Energy Rating Council, AERC, that we're active with, and are launching a new rating system for commercial secondary windows, as well as they already have a program for low E storm windows on the residential side. So I encourage you to look that up or ask me about it if you're involved with those types of products. And then the last thing I want to point out, it's a little weird, but people forget that a new building instantly becomes an existing building once it's occupied. That sounds a little weird, but what that means is that existing building limits will apply as soon to a new building once it's occupied. So architects and designers it will hopefully help push longer term thinking for the building owner, and that they need to think long term, because these fines will potentially apply to them not just day one, but down the road. So it might help with reducing short-term value engineering. All right, lastly, I'm going to try and crank through this, just a couple more slides on Canada, to our neighbors to the north. So they're finalizing their National Energy Code, NECB, for 2020. They're trying to finish that this fall, and they're committed to a net zero energy ready model building code by 2030, and in their efforts to address climate change, the Pan-Canadian Framework for Clean Growth and Climate Change. And this is putting strong pressure to advance the NECB. And then on top of that, some provinces are using their own aggressive performance-based codes, most notably the STEP codes in British Columbia, and then the even more aggressive zero emissions building plan in Vancouver. So Canada's being very aggressive about energy efficiency. So part of this is there are a number of proposals, and we filed detailed comments on 3 of those, in reduced window area, U factors, and door air leakage. So the window area, in ASHRAE, they just have a flat 40% window area prescriptive requirement. Anything above that, you have to make up for in the performance path. In the NECB, they have a sliding scale. It starts at the 0.4, where a lot of the Canadian population is, but then it kind of scales down all the way down to 0.20 in the Arctic. And then on top of that, they have a proposal that would arbitrarily reduce that by another 0.10, which is a 25 to 50% reduction. And we have a lot of concerns about this because it ignores all the numerous studies showing that this will cause harm to occupant health and well-being. When you reduce access to quality daylight and views, you are actually harming the performance of students and office workers and patients and healthcare recovery costs and real estate values. And so that was part of our detailed comments that we filed. And it conflicts with other energy and green building standards. It's really, reducing window area is not a good thing for high performance buildings. And then on the U factor side, they have a proposed reduction to U factors in all zones, which is for Canada, zones 4 through 8. And they're shown there in both SI and IP units. It's very aggressive. It goes beyond the ASHRAE 90.1 and IECC newest values that I showed earlier. But they are achievable, very aggressive, but achievable for fixed fenestration, curtain wall, storefront, window wall, fixed windows. But it's a problem for operable windows. Operable windows are different. The way NFRC rates them at a different size, and even if you have the same type of glazing and framing in general, you will have a different U factor. And so by just having a single U factor, it's inconsistent with ASHRAE and IECC, which do account for that by having different U factors for fixed and operable products. So that's some of our concerns. So what happened? Because we had a lot of debate over this just wrapped up a couple weeks ago, actually. So this was debated during standing committee meeting and then at 2 envelope task group meetings. And initially, the task group members wanted to reject all our comments and just citing pressure to get to net zero in 2030 And then also trying to say that human health impacts that we were raising were out of scope, which is really a flawed way to look at the energy code. So there's a lot of debate with a number of people, and I wanted to say a big thank you to Jeff Baker. I don't know if he's on the call or not, but he's a big part of the debate and has been active in Canadian energy codes for years, along with the Canadian builders and Canadian fenestration industry. So it was a big debate. And then we ended up coming up with a compromise where they agreed to drop the reduced window area proposal, which is our biggest concern. But they are going ahead with the U factor changes. And like I said, it's aggressive but achievable for fixed products. It is problematic for operable windows, but you can comply by averaging the fixed and operable products together or using trade-offs in the performance path. So this was kind of the compromise, and they did finally agree to our concerns about the window area. They're also going to make corrections to the door air leakage requirements that we raised, where it's really technical corrections. They just simply had the wrong numbers in some places. So this still needs to go back to the standing committee, but no further changes are expected. So I know we went a little long, but I was trying to pack a lot in. But now I'm happy to stay on for as long as people like to answer questions. I think Sarah, I've not been looking at the chat, but I think Sarah hopefully has and will be bring up any questions. You can continue to put them in the chat box as well. And then also, of course, feel free to reach out either to myself or Irma Lasalo after the presentation for more details in any of these areas. Sarah, do we have questions?
We do have a couple we've already received. The first one is, why is there not more pressure to improve the U value of frames? For instance, in Europe, there are framing systems using much better thermal breaks and are able to meet a 0.25 U value without triple glazing or interior surface coatings.
Yes, so I assume you're talking commercial, and and I would say that that is there. Two important points. Number one, European U factors are different than U factors used in the US and Canada. They're calculated under a different standard. And so it depends on the exact product, but like a 2.5 in Europe might be a 2.6 or maybe even a 2.7, depending on the product type in America. But the point's well taken. And I think that has been addressed by this latest version where you look at heavy commercial architectural products, because we also have higher structural loads in the US than in most of Europe, higher wind loads, higher structural requirements. So when you account for that, these U factors do require these advanced thermal breaks. These are, like I was mentioning, these are the wide, not just like, you know, a little wide, like very wide strut systems or complex shapes, the double pour into bridge polyurethanes, or there's some new foam or composite materials that kind of incorporate both. And then, of course, you know, if you can meet the structural performance, there are other material types like fiberglass and so forth that can be used, although they will have, they tend to work a little better in punched openings, have a hard time meeting some of the span and wind load requirements in the US. But yeah, so I think you will see that push more towards that type of improved framing as these newer codes are adopted in the States.
Great. There's a couple of things related that I think it might be helpful to pull up either slide 13 or 14 again. Did you indicate that with ASHRAE 2019 that each climatic zone will have to be improved by the next zone down? For instance, zone 6 performance is now 5, 5 is now 4, etc.
Generally, don't, you know, it's not always exact, but you know, the I'm trying to find a good example. So zone, well, what was a good example? 2016, you know, you were just kind of notching, it's the technology. So like, you know, in 2016, you could use a 3.8 up through zones 4 and 5, and then you jump to a 3.6 in zone 6. Now that 3.6 is now moved down to zones 4 and 5 in the 2019. You know, in some of these lower numbers like 3 3s, 3 4s, I have jumped like from zone 7 back here to zone 6 now, and then we're having kind of a 2 9s and up in zone 7, and then zone 8 is making another step. So the exact numbers, it's not exactly, but when you look at the actual technologies that are used, like I could jump ahead to that. Maybe I'll do that to the very end. When you look at the actual technologies, it ends up being roughly a zone switch. So here we go. Some of you have seen me present this slide before. I'm not going to go through all of it, but this is a rough guideline for what's needed to meet the U factors in different zones. And in 2016, you can look by your zone. And so let's take zone 6. You needed low E, a standard thermally broken frame, and then pick 2 out of the things on this list. So the cheapest, most likely, would just be argon and warm edge spacer, or you could do argon and a better thermal break. Now, when you go to 2019, very often I updated this list. It's like instead of picking 2 items, it's pick 3 items. Zone 7 was pick 3. Now you have to use all of these things or go to triple. And that's kind of what I mean, like by it's a zone shift. Not exact, but in general, that you can. You're going to use the same types of products. You're just going to use them further south. So zones 4 and 5, maybe you just in the previous code just used low E, standard thermal break, and argon. Well, now you're going to have to add something else to that, like a better thermal break or a warm edge spacer or a forced surface low E.
Okay. Another related question. Why is there such a sharp reduction in U factor for commercial entrance doors from 0.77 to 0.63 in ASHRAE 90.1?
Yeah, that's a good point. So we went through and just kind of surveyed some of the manufacturers, we meaning the ASHRAE envelope subcommittee, reviewed some of the thermally broken products out there for the commercial entry doors, and found that 6.3 number was achievable and available and cost effective. Is the simple answer. So it is kind of like taking that next step. I'm going to go back to the other slide. But there are allowances for doors are pretty easy to average in with the rest. So I mean, but yes, there are steps here from 7.7 to 6.3. If you have a really wide style, even thermally broken, it might be a little tough on the 6.3, but for narrower products, it should not be a problem. And if it is a problem, you'll find mixing in the small area of doors with all the other area weighted average with all the other window products, it's pretty easy to accommodate that.
Okay.
And I believe the U factors in Canada are going even lower than that. So.
Okay, one more question related to ASHRAE, and then we'll move on to a different subject. But to propose changes to the next ASHRAE 90.1 regarding spandrel, how early do those need to be presented?
As soon as possible. If you have, whoever that is, please contact me because I need as much help with that as possible. We've realized that it's an issue because they basically just set the wall requirements based on walls, and then they said as an afterthought, well, spandrel, let's just treat it like a steel stud wall because it's kind of metal framing. So they're treating it like a steel stud wall with foam insulation on the outside, and what I can't even remember if it's 16 or 24-inch spacing, but clearly not like a spandrel. And they are starting to recognize it's not a good way of doing it. And so we're just starting that process of like, all right, do we need a separate category for spandrel? But how do you do the numbers? The NFRC is working on a better way to rate and validate spandrel U factors. But the next step is we have to come up with 4 common configurations. What is a realistic spandrel number that pushes energy efficiency? But then we also have to deal with all the other nuances in spandrel of, do you allow the insulation to be in contact with the glass or not? How do you deal with moisture, things like that? So I would encourage whoever asked that question and anyone else interested in that, please contact me and maybe we can kind of form a little sub-work group to present ideas to ASHRAE.
Great. Two more questions. What do you think is the biggest practical effect of California for the nearest future?
The biggest kind of, stepping back, residential, it's single family home, it's already switched to kind of these newer, lower triple silvers. There's a nuance there that we're learning about, that the wall requirements have changed dramatically. And so builders are doing an unusual thing in California where they are to lighten up on the wall insulation requirements that are sometimes difficult. They're putting in triple glazed windows in some parts of California and using, they're putting better windows and using that as a trade-off against the wall insulation. So that you might see in California on the residential side. On the commercial side, you're going to see a continued triple silver low E market, but increased use of kind of these newer triple silvers that have a lower solar heat gain. There's several companies that provide those. I'm specifically not using their names, but there's at least 3, if not 4 or 5 that offer those, or a low E on tent. And then probably the other big change is in places like Southern California. I'm not sure that everywhere there is using thermally broken frames and argon. They should be, but I've also heard they're not. And this will kind of force fabricators in that area to have that technology if they don't already, and hopefully have better frames using argon, gas fill, bringing in warm edge spacers if they don't have them already. It's all available technology. It's just some of the local fabricators may not be used to it yet. So there'll be some, I guess, education and helping to accommodate that. But otherwise, it's really nothing too dramatic. It's just things that people are already used to in northern zones are going to be going into California.
Okay, a couple more questions are still coming in. For existing buildings, you mentioned a few jurisdictions, New York City and Washington, have time-bounded performance requirements. What about incentives, such as rebates in those or other jurisdictions? Is there any reference you can point to about incentives?
Yeah, that's a tough one because it's scattered all over the place. Most incentives are run through utilities, or it can also be like a local efficiency program. Like here in Wisconsin, we have Focus on Energy, which is a efficiency program, but it's funded by the utilities. And so and of course, everywhere has different utilities. So you have to look at a very regional level. In New York area, it's Con Edison. You can look at but maybe a way to start on the residential side, the Efficient Window Collaborative, and if you know Carrie Hagelin, she runs that. It's in the past, they've gathered information on utility incentives. I know for residential windows, I'm not sure if that's for commercial as well. You can look at the big utilities. There's also the Consortium for Energy Efficiency. That's a consortium of the energy efficiency program managers for utilities, especially the smaller ones. So and they'll help write incentive programs that are adopted by smaller programs. So I don't know, I haven't looked lately, but they may have information on their website. And then the last place would be around the US, there's regional efficiency associations like MIA and NEA and NEEP and SWEEP. They all have these acronyms, meaning like NEA is the Northeast Energy Efficiency Association, and there's one for each part of the country. SWEEP is for the Southwest, and things like that. You can look those up, and they'll usually have information on local incentives, but it is scattered all over the place.
Okay. Next question, is ASHRAE working toward a net zero energy building for Edition 2031?
Yes and no. The ASHRAE board as an organization has high-level goals and a kind of a target pathway towards net zero buildings. But because ASHRAE 90.1 and ASHRAE 189.1 and ASHRAE 90.2, that's a residential one that nobody uses, at least not yet, but they might. But anyways, those standards are all ANSI standards, and the board is not allowed to tell them what to do or even set goals. So the committee can say, forget you, we're going to do whatever we want. And none of those have net zero goals in place. They're all bound, well, 189 as a green code's a little different, but the other ones are bound to meet cost effectiveness targets. And so they can make a step each cycle pushing basically as far as meets their cost-effective targets and what is technologically feasible and available. So as prices come down for new technologies, then that factors into the code. And that's because, for instance, ASHRAE 90.1 is referenced in federal law and the EPACT, Energy Policy Act. And so for that reason, it has to meet certain cost-effective targets that DOE tracks, and they can't be just an aspiring code. So yes, many people on the committee want to head towards net zero, and that's one reason that we started looking at these minimum prescriptive requirements for on-site renewable energy, but it's not an absolute requirement, and it's really up to public consensus and public comment on what's achieved. I will note, though, on the on-site renewable energy, we had to meet those cost-effective targets, and the pricing on PV has come down so much, even without any federal or utility incentives, that we were able to justify that. So, so that's an example where pricing changes, you can push more towards net zero. But it's a little different than like kind of Canada, where they were, through their governmental policy, allowed to push for a net zero target. So a little different framework.
Okay, our final two questions. Most projects in California use the performance path, so that's why no thermally broken framing or warm edge spacer or argon. Most projects in California use the performance path. And how is that related to thermally broken framing and spacer fill?
Yeah, and that is one option. You know, performance paths are there to provide flexibility, and you must show energy or equivalent or better energy performance, but that does allow you. It's the yin and yang of performance paths. The whole point of it is to allow ultimate flexibility for the building owner and architect and designer, but that does also mean they can make trade-offs. And so we have heard that in California, and about, you know, that people do that. They will put in a little better insulation, or they'll put in a little better lighting system, and they'll use that credit to, you know, value engineer and take out, you know, a spacer, or take out the argon and so, or a thermally broken frame. I think it's up to our industry to try and push to avoid that. You know, value engineering is there for a reason, but to point out the negatives when you do that. Are you creating, by ignoring the perimeter, the framing and the spacer and all that, are you going to create condensation issues in certain areas? Are you creating other potential problems, moisture problems, things like that when you do that? And so we have to kind of really push to preserve those attributes in there. But yeah, I would agree that that's a true statement, that they're linked.
Okay. Is the additional credit in the IEC 2021 mandatory? And if so, is there a minimum required to achieve?
Yes, it's a required that you achieve a certain number of points. And then the points you earn are based on the building type, like whether it's a school or an office building, and depends on your zone. And but how you get those points is there's a wide range. I listed the 3 that where glass is involved, or fenestration systems are involved, but there's also things for mechanical systems that go beyond federal minimums, and lighting systems, and better, well, I mentioned air leakage. There's a whole list of things you can do to do that. It is required that you achieve a certain number of points, but it gives you choice on how to do it. I will say, though, that there's a similar system in the 2018 and 2015 IUTC. It's not a full-on point system, but it's an additional efficiency measure that they just give a simple list and say, pick one. And a lot of states have amended that out. And so it really depends where your project is. So some locations have taken that extra bit out and say, just meet the basic energy code. So you'll have to watch, and this is true always, wherever your project is, look at the local code. Use the national model code and my slides and things like that as a guideline, but you always need to check the local code, see if there are any local amendments, things like, oh, they took that out, or oh, they actually tightened the U factors beyond what was there before. You know, it can go both ways.
Okay, great. Well, we have been on for an hour, and we will need to call this presentation a wrap. We have noted a couple of additional questions that have come in since, and we will make sure that those get addressed offline, either between Tom or Irmela Sowell on staff. If technical codes and advocacy is of interest to you, we encourage you to check out both NGA's advocacy committee, and for an even deeper dive into codes and advocacy, our glazing industry code committee, where you work hand in hand with Tom and our other code consultants to help shape these to benefit the glass and glazing industry. Thank you again for attending today's webinar, Tom, for sharing your expertise with all of us. We did want to point out that Tom will be joining us and other members of our technical and advocacy team to address more information on codes and standards activities, as well as a session on most asked questions by architects that you won't want to miss at our NGA Glass conference. Please do take a look at the program, which is posted on glass.org, and we hope that you will decide to register and share it with your colleagues. Also, as placed in the chat, we appreciate your feedback on today's session by taking just a brief survey. Tom, thank you again. We appreciate it.
You're welcome.
Have a good rest of your day.
Thank you.